In this video, we're going to look at histogram charts. Histogram charts are good at showing how your data is distributed. For example, if we had a data set showing how many daily hits a website received over the period of 12 months, we might want to know how many days within that year received between 100 and 150 hits, and then how many days received between 150 and 200 hits, and so on and so on. A histogram groups values into what are called bins. Now, the default bin width or size is determined by a formula called Scott's normal reference rule. Now, you don't need to know this formula, you just need to know that is the rule that will define the size of your bins automatically. More information can be found about this reference rule by following this link on this worksheet. As well as accepting the default bin size, you can also set your own bin width. We will look at how to do this with a couple of examples later on in this video. For our first histogram chart, we'll take a sales example. Here's my data. I'm going to click into it. Then I'm going to go up to the Insert tab on my ribbon. And then in the Charts group, I'm going to click the Statistic Chart button. And the histogram chart is the first chart in that menu. For this data, Excel automatically creates 3 bins, and you can see the range of values that each bin represents. Now, you can set your own bin sizes, as I mentioned at the beginning of this video. To do that, double click on the horizontal axis. That opens up the Format Axis task pane on the right of your screen. You can see the setting is currently automatic, but if I went down to bin width and selected that, I can change the default bin width to something of my choice. So for example, 100. So with a bin width of 100, I get a lot more bins. And what you can do is play around with the bin size to analyze your data in different ways. You can also set the number of bins. So if I set the number of bins to 8, Excel would automatically work out the width of each bin for me. I can also set an overflow bin and an underflow bin. To do this, let's set our bin width back to 100. So I might say, for example, that I want the overflow bin to contain all values that are greater than, let's say, 850. So you can see my last bin is now defined as greater than 850. An underflow bin works in a similar way. So I might say, for example, that my underflow bin contains all values that are less than 100. So for our second example, we're going to take a data set that records the number of hits a website receives for each day over the period of 12 months. So I'm going to click into the data, go up to the Insert tab on my ribbon, go over to the Statistic Chart button and select the Histogram chart. Just making the chart slightly larger for you. You can see the width of each bin on the horizontal axis. These widths are defined by Scott's rule. I can change the width of the bin by double clicking on the horizontal axis, which brings up the Format Axis task pane on the right of my screen. So I could set my bin width to 100 if I wanted to, and that would give me that bin width with the necessary number of bins. There is a setting within histogram charts that allows you to change the gap on the chart between each bin. Traditionally, however, you would show your histogram chart as it is shown here without any gaps between the columns. If you did want to add gaps between the columns, this is how you do it. You double click on one of the columns, and that will open up the Format Data Series task pane on the right of your screen. And here we have a setting for gap width. So if I take this slider and drag it to the right, you can see that it increases the gap width percentage. And this is the effect of the gap width percentage on your chart. But as I said, traditionally, the gap width is 0% for histogram charts. I hope you have found this video tutorial useful. Why not experiment with some of your own data and create your own histogram chart?